Hello everyone, my name is Murad Hosseini and today I'll be presenting my individual technical presentation on API development. This topic is one of the most important areas in computing today because APIs power nearly every application and service we use, from social media to online payments. Here's what I'll cover today. First, I'll explain what an API is. Then we'll see how APIs work, followed by a quick comparison between REST and GraphQL, two popular API architectures. Next, I'll highlight API security and best practices, and finally, we'll look at real-world examples and the importance of API development. So what is an API? API stands for Application Programming Interface. Think of it like a menu in a restaurant. As clients, we make requests for certain items, and the kitchen, which is the server, sends back the results. In the same way, API defines how software systems communicate, specifying what kind of requests can be made and how responses should look. In short, APIs are the rule books that enable different programs to talk to each other seamlessly. When an API is used, a client sends an HTTP request to a server. The server processes that request and returns a response, usually formatted in JSON, which stands for JavaScript Object Notation. For example, a client might send a request like get users /123, and the server responds with something like name Murad Hosseini, email melhossein@asu.edu. These APIs typically run on cloud servers to ensure scalability and allow constant updates without downtime. So for our comparison between REST and GraphQL, two major styles of building APIs. REST uses multiple endpoints like /users or /posts, while GraphQL uses single endpoint that lets clients ask for exactly the data they need. REST gives the control to the server about what data to return, but GraphQL gives more control to the client. In general, REST is simpler and widely used, while GraphQL is more flexible and efficient, especially for complex data requests. Next up is API security and best practices. Security is one of the most critical parts of API development. Developers often use API keys, OAuth 2.0, or JWT tokens for authentication. These make sure that only authorized users can access the API. Rate limiting is also implemented to prevent abuse, like too many requests in a short amount of time. Another best practice is validating inputs and sanitizing data to prevent attacks such as SQL injections. Finally, all communication should always use HTTPS to encrypt the data between the client and server. So some real-world examples and applications. It's literally around us everywhere. For example, X's API, previously Twitter, allows developers to access tweets, mentions, and analytics. And then the Google Maps API, which is a common one, provides location and navigation services used in apps such as Uber, Lyft. And then the Stripe API securely processes online payments for thousands of businesses. These examples show how APIs allow developers to connect services and create seamless user experiences. So why does API development matters? So API development is important because it encourages modularity. Each system or service can evolve independently while still working together. It also promotes integration across platforms, web, mobile, and even IoT devices. And most importantly, APIs form the foundation of cloud computing and DevOps workflows, enabling automation, scalability, and innovation. My research and examples were supported by reliable sources such as Red Hat, RESTful-API.net, developer.mozilla.org, and Akamai's API security fundamentals. These resources provide deep insights into how APIs are structured, built, and secured. To conclude, API development connects everything we use in the digital world, whether it's sending a message or requesting a ride or checking your bank account. An API is working behind the scenes to make it happen. Thank you for listening.